Inverse functions today. Every function has an inverse, but the inverse may or may not be a function. Remember that a function is a relation in which each value of x has only one value of y, so the x's do not repeat. You can find the inverse of a function by switching the x value and the y value. In each ordered pair. The symbol for inverse, hopefully you remember, the little -1. So the inverse of g would be written as, if I can get the g to right, g, it looks like g to the negative first, but that is read as the inverse function of g. So as we look, some examples. We have a function 1, 3, 2, 5, 3, 7. Our domain, if we listed that, would be 1, 2, 3, and our range, which is the y values, would be 3, 5, 7. So I don't know if that green's showing up really well. We'll use a different color. So to find the inverse, we switch our x and y values. So our first ordered pair becomes 3, 1. Our second ordered pair is 5, 2. And our last ordered pair becomes 7, 3. Is it a function? Yes. Because x's don't repeat. It's a function because the x's don't repeat. We look at the next one. We have the function, f of x is 1, 2, 2, 2, and 3, 4. So our domain is 1, 2, 3 again. Now our range, though, is 2, 2, and 4, but we just listed it as 2 and 4. We want to switch our x values and y values. So our ordered pairs become 2, 1, 2, 2, and 4, 5. Is this one a function? No. X's repeat. So it is not a function. All right. Now we have actually an equation. F of x equals 2x minus 3. That's the same thing as saying y equals 2x minus 3. Our domain for a function like this, it's a linear, is all reals. And we use the symbol for all reals for both domain and range. The inverse, so we switch our x and y's. X equals 2y minus 3, and I want to solve for that. X plus 3 equals 2y, and so I would have x plus 3 over 2 equals y, and that's my f inverse of x is x plus 3 over 2. Now, the last one, f of 7 equals 9. Think about it this way. Normally that would say f of x equals something. We're saying f of 7 equals 9. So that 7 is replacing your x. and the 9 is your y. So then to write it as an inverse, we would say f inverse of 9 equals 7. We just flipped them around. Alright, so moving forward, we want to answer each question. A function g of x has an inverse called g inverse of x. Find the value of the function and its inverse. Use the fact that the inverse can be used to undo the original function. So if you think about that, if g of 3 is 4, then g inverse of 4 has to be 3. If g inverse of 2 equals 1, then g of 1 equals 2. If g inverse of 8 is 7, then g of 7 is equal to 8. You should know how to describe how you find the inverse of a relation. You switch your x and y values. Switch x and y values. Just switch them. So when we're writing our inverse of r, make it r inverse equals, and then in parentheses. We switch, so it's now negative 1, negative 1. 1, 1 stays as 1, 1. Negative 2, 4 becomes 4, negative 2. And 2, 4 becomes 4, 2. And then we close it. Is it a function? Obviously, no. The x values repeat at 2 different points, at 1 and 4. So the x values repeat. All right, so let's move to the back of the page. So flip it over. We have some examples. But first we have, so it's hard to see, but using what you know about inverses, domain and range, we can find the inverse of any function. To find the inverse of any function, use the following 4 steps, and they're actually very simple. First thing we want to do, we want to substitute y for f of x. And then, like we've said before on inverses, switch x and y. We solve for y, and then replace y with f inverse of x. So substitute y for f of x, switch x and y, solve for y, replace y with f inverse of x. So let's try number 1. F of x equals 3x plus 4. So step 1, replace f of x with y. Step 2, switch them. Switch x and y. So x equals 3y plus 4. Step 3, solve for y. We're going to subtract 4. So this becomes x minus 4 is equal to 3y. We're going to divide by 3. So we get y equals x minus 4 over 3. And our last step is we say f inverse of x equals x minus 4 over 3. I'm just going to do a couple of the examples. So I'm going to do 3 and 5 as well. I'm not going to do 2, 4, and 6. So with 3, we rewrite it y equals 1/4 x plus 7. Then I'm going to switch x and y. X equals 1/4 y plus 7. Then I'm going to solve. I'm going to subtract 7. X minus 7 equals 1/4 y. How do I get rid of 1/4? Multiply by 4. So that's going to give me 4x minus 28 equals y. And then finally, I'm going to rewrite that as f inverse of x equals 4x minus 28. And so you can see with when you have a fraction like 1/4, to get rid of that fraction you need to multiply by its reciprocal. In this case it's just 4. So we multiplied both sides by 4. But if you look at number 4, you will eventually have to multiply both sides by 3/2 to get rid of that 2/3. And so let's look at number 5. So 5 says f of x equals negative 5/4 x minus 2. That's going to be y equals negative 5 over 4 x minus 2. So I'm going to switch x and y. X equals negative 5 over 4 y minus 2. Now I'm going to solve. So here I have to add 2 to both sides. So I'm going to say x plus 2 equals negative 5/4 y. Now how do I get rid of that negative 5/4? I multiply both sides by negative 4/5. And that will give me negative 4/5 times x plus 2 equals y, which is f inverse of x. Okay? Looking at number 7, you can use the calculator to graph it. Just finding the inverse is pretty easy. Y equals x plus 2. X equals y plus 2. Switch them and subtract 2. X minus 2 equals y. So our final answer is f inverse of x equals x minus 2. That is a linear function. When we graph it, you can see it's a straight line. Domain and range are both all reals, and to say that in set notation, I would say the set of all x's such that x equals all real numbers, and for the range I would say the set of all y's such that y equals all real numbers. That is where it ends.